Welcome back to Miss Corrigan's Year at Maths class. Today's exercise is figuring out the area of a circle, exercise 10D. Now, if you want to find the area of a circle, you need to use the formula A for area equals pi times r squared, the radius squared. Okay, let's look at an example. We have got, in question 1b, we have a circle which has a diameter of 2.5 kilometers. Now to work it out, we need to use this formula. The area equals pi r squared. Now, what's our radius? We know our diameter is 2.5 kilometers, but that's not our radius. How do we figure out our radius? Our radius is half of our diameter. So we need to take that 2.5 and halve it. And that gives us 1.25 kilometers. So we're going to use that as our radius. So let's go across to our sum, and we have area equals pi times 1.25 squared. Remember, that's 1.25 times 1.25. I'm going to go and plug that into my calculator. Okay, when I plugged pi times 1.25 squared into the calculator, I got this. I got 4.90873852213, so on and so forth. You don't need all those digits. I'm going to simplify that. I'm going to cut that off at the 2 decimal point. I'm going to cut it off there. The next number is an 8, so that means I must wind the figure before up 1. So my answer is 4.91 kilometers squared. Okay, let's move on to question 3b, where we have to look at an annulus. An annulus is a ring, so we have to figure out the area inside the ring. And to do that, we need 2 radiuses, one larger than the other. Let me show you with question 3b. Okay, in question 3b we have 2 rings. The little one in the middle is 7 centimeters. The larger one to the outside is a grand total of 41 centimeters. It looks like a record to me. When you want to find the area of an annulus, you need to use this formula. What we have is we have the area of one ring, the larger ring, minus the area of the smaller ring. So we're going to find the area of this ring with the 41 centimeter diameter minus the area of this 7 centimeter diameter ring. Let's do it. So I'm going to use pi times the radius of this larger ring. Because it's 41 centimeters, I want to cut it in half. And half of 41 centimeters is 20.5 centimeters. Okay, I've got to subtract the area of the smaller circle away from that. The smaller circle is 7 centimeters, so I need to do pi times 3.5 squared. Oh, don't forget to square the first one. I nearly forgot that. And of course it's still in centimeters. Okay, pi times 20.5 will give me 1320.25. I'm going to round it off to 2 decimal places. Minus 38.48, and both of these measurements are centimeters squared. Now, as you work through the exercise, things are going to get trickier. And one question I want to give you a start to is question 4E. Question 4E steals its concept from yin and yang. Yin and yang is an ancient symbol which tries to show that the world is divided into two. The idea of this circle is that it's really a semicircle. Let me show you. Okay, I've drawn a line that is pretty much right between the two eyes of each circle to show that it really is, when you divide it, a very, very equal shape. So when you're doing question 2E, treat it like a semicircle. That means you only need to find half of the area. Okay, I think you guys should now be ready to get on with chapter 10C, just working with circles. So here's a clover for good luck. And remember, as per usual, if you have any troubles with the question, you can ask your teacher, you can look at the worked examples, or you can watch this video again.